Hello, this is Mr. Agbamu Idanagwene. I'm here to teach coordinate geometry in mathematics, and in today's topic, I'm going to focus on this objective to determine the coordinate of points of intersection between two lines, then solve problems on conditions for parallelism and perpendicularity. So in our last class, I taught angles between 2 points, and I derived the formulas you can use to calculate the angles between 2 points. And I also said that when you know the angle between 2 points, there are two conditions that are very important in this topic, which is parallelism and perpendicularity. So when two lines are parallel, what is the condition? In that class, I said the condition for two parallel lines is that they have equal gradients, while the condition for perpendicular line is that when you multiply the two gradients, it's going to give you -1. So I want to solve example on this, and that is my second objective. Then the first one is about intersection of lines. This is another important aspect of coordinate geometry, which is very important. In this topic, as I told you from the beginning, you don't necessarily need to plot the graph of the lines, but you should be able to find the point of their meeting. So when you have two lines, how do you get the point of meeting? All you just need to do is to solve the equation of the two lines simultaneously. That is all you need to do. It's very important. So what I'm trying to say is, let me put it in words. When you are asked to find point of intersection, all you just need to do is the point of intersection between two lines, intersection of two lines is obtained by solving. You solve them simultaneously. It's obtained by solving the lines simultaneously. So that is all you need to do. So when you are asked to find the intersection of two lines, all they want you to do is to solve the two lines simultaneously. So the two answers you are going to get in your simultaneous equation is going to be the coordinate of the points. So this example will help us to understand what we are talking about. So let's study the example together. Let's see. Okay, let's put S here. Okay. So we have this, I picked this from WAEC past question paper 2018 number 2B. It's a theory question. And they gave us two lines. You can see they said two lines, 3y minus 2s equal to 21 and 4s plus 5s equals to 5, intersect at the point Q. See, there's a point of intersection, and that point is called Q. Then has to find the coordinate of Q. So the question did not say you should plot any graph, but if you wish, you can plot the graph of the two lines. Then wherever the two lines meet, you trace it on the x and the y axis. From there, you get your two coordinates. You will still get the answer in that way. But instead of doing that, why not solve it simultaneously? The two answers you get for your x and y, that is the point of intersection. So that is the best way to do it when you are trying to avoid using graph. Because sometimes using graph to solve this question, it may take time. And you know there are other questions you may want to answer. So how do we do this now? The first thing to do is bring out the two equations, since we said we want to solve them simultaneously. So bring out the first equation, which is 3y minus 2x is equal to 21. So you can call this one equation 1. I'll call this equation 1. Then you do the same for the second equation, which is 4y. 4y plus 5s. 4y plus 5s is equals to 5. So we can still take it. So this is equation 2, just to label the two equations. Okay. Now that I've labeled the two equations, let's start now. What do you need to do now? You know your method of solving simultaneous equation. You can use any of the method you like. You can use substitution method, elimination method. You can use matrices method, determinant, any method you like, even graphical method. You will get the same answer. Okay, let me just use elimination method here. All I need to do in elimination method is to make the coefficient of y or coefficient of x in both equations to be the same. So based on what I want to eliminate, if I say let me eliminate, so let me using elimination now, using elimination method. If I'm using elimination method, then what do I want to eliminate? So using elimination method and eliminating, so if we eliminate and eliminating, let's say eliminating x, So if I want to eliminate x, what am I going to do here? That means I'm going to multiply the coefficient of x in the first equation by each of the term in equation 2. Coefficient of x in equation 1 times each of the term in equation 2. And I'm going to put it in this way, that is, coefficient of x in equation 1 is minus 2. But let me use positive 2 to do the multiplication. So which is 2 times, you open bracket, 2 times equation 2. And this is going to give us what? This is going to give us 2 times equation 2 is going to give us, so 2 times 4, I'm going to have 8y. Then 2 times 5, I'm going to have plus 10x. Remember what I am using, I'm not using the minus 2 to multiply, I'm using plus 2 to multiply. I can still use minus 2, I will still get the same result. All I'm trying to avoid is negative. I don't want minus to be in each of these terms in the next equation. When you have so many minus, sometimes you may make mistake while solving. So if you use the positive 2 to times, 2 times 4 will give us 8y, 2 times 5, which is plus 10x, then equal to 2 times 5 is going to give us 10. So this is another equation. You can also label it as equation, let's say equation 3. Okay. Then the next line, I need to multiply 5 times equation 1, which is 5 times equation 1. So what does this mean? It means that 5 is going to times each of the term in equation 1. 5, coefficient of x in equation 2 is going to times each of the terms in equation 1. Then how am I going to do this? Then I'll start with 5 times 3. 5 times 3 will give us 15y. Then 5 times minus 2. Take note, the minus 2 you use to times 5. 5 times minus 2, I'm going to get minus 10. Minus 10x. Then equal to, then the next thing is 5 times 21, which is going to give us 5, which is 105. So 5 times 21 is 105. So you can also label this as equation 4. So that is that. So you can see these two equations now, equation 3 and equation 4, you can see that the coefficient of x, they look alike now. So we can easily eliminate a value now, eliminate x out of this equation. So that is what we mean by elimination. Using elimination method by eliminating x is to use the coefficient of x to times each of the term. This is minus 2, but I decided to use plus 2. So I will still get the same result even if I use minus 2. So don't be afraid of that. The most important thing is when you get your final two coefficients that are the same, all you need to do, you can add or you subtract. In this case, I'm going to add equation 3 to equation 4. So when I add, so say add, just say add 3 to 4. When I add equation 3 to equation 4, I'm going to get equation 3 plus equation 4 when we add them now, we are going to get, let me move up a little. So this is 8 plus 15. So you add them correspondingly like that, 8y plus 15y. So let's put it now. So you have your 8y plus 15y. Then the next term now is plus 10x. So we are adding, remember, plus 10x plus minus 10 plus minus 10x. No, we are adding each of them plus 10x plus minus 10x. Take notes, minus 10x will be in bracket. Then this is equals to 10 plus 105. Then let's solve this now. So 8 plus 15, this is going to give us 23. We're having 23y. Then 10x plus minus, when you open this bracket, this should be 10x. This is going to give us plus 10x minus 10x. No, minus times plus, when you open the bracket, it's going to give you minus. Then that is minus 10x equals to then 10 plus 105. This will give us 115. Then finally we have 23. We have 23y. 23y will be equals to, this is 10x minus 10x is 0. So since it's 0, I don't need to write it down. 10x minus 10x is 0. So 23y is equals to 115. Then the next thing is to divide both sides. Need to divide both sides. Divide both sides by 23. So when you divide both sides by 23, you are going to have y is equal to 115 divided by 23. So which will give us our final answer for y. So y is equals to, so 115 divided by 23, what are we going to get? Let me just do it here very fast. 115 divided by 23 is equals to 5. So y is equals to 5. So that is my answer for 5 for y. So the y coordinate is 5. Take note of that. Then the next thing is to, let's solve it here now. The next thing is to substitute the value of y, put it in statement. Substitute the value of y into any of the equation you wish to substitute. So you just need to substitute the value of y into, you can put it any of the equation you wish, equation 1, 2, 3, 4, any of them, you get the same answer. Let me just put it in equation 2, since it's a very simple equation, the numbers are not large and it does not have negative. It's always good you try to avoid negative while solving equation, to avoid mistake. So let's put it in equation 2. Okay, so now that we are in equation 2, all I need to do now is to substitute the value of y into equation 2, so which is 4. I'm going to have 4y, then y will now be replaced with 5. So you put it in bracket because it's multiplication. So 4 times 5 plus 5x, this will be equals to 5. Then the next step now, 4 times 5, you have your 20 plus 5x, this is equals to 5. Then collection of like terms, collect your like terms, 20 is coming down to this side, it will now be 5x equal to 5 minus 20. Then next thing is 5 minus 20, this will give us minus 15. So 5x is equal to minus 15. And the next thing is to divide both sides by, when you divide both sides by 5, you are going to get x. we're going to get x is equals to minus 15 divided by 5, and this will give us our final answer. Minus 15 divided by 5, this is going to give us x is equals to minus 3. And that is the end of our solution. Then, since we said the answer when they say intersection is to solve them simultaneously, now say therefore now, okay, therefore the coordinate of q, that is what the question says we should find. So what is the coordinate of q? So find the coordinate of q. So therefore the coordinate of q is going to be x is minus 3, comma, y is 5, minus 3, 5. So this is the coordinate of q, and that is the answer to this question. Very simple and easy. So take note of this. Anytime you are asked to find the coordinate of a point when two lines intersect, just solve them simultaneously, and that is all with that. So it's a very simple question. If I want to demonstrate this in graph paper, let me just demonstrate it very fast. The first equation they gave is 3y minus 2x equals to, let me check it again. These are the two equations. 3y minus 2x equals to 21. All I just need to do is to type it here. You can see this is the line. Then the second equation I have here is 4y plus 5x equals to 5. 4y plus 5x equals to 5. So you can see where they meet. You can see where both lines meet. So this is the point of intersection. So if you trace it downward, you can see that x is minus 3. If you wish to do the point of intersection, you can check it here. So the 2 points where they intercept, you can see they intercept at point A. And what is the answer of point A now, which is minus 3 for x, 5 for y is 5. So that is the answer, minus 3 and 5. So take note of that. Okay, so that is the answer to the first question. That is all. So let's look at the second objective. Let's solve an example on problems on parallelism and perpendicularity. Let's see the next example I have here. We are not going to waste much time on the next example because we have already explained the condition for perpendicular and parallel line. So example 2 says, we pick it from WAEC question 2016, and it says we should find the equation of a straight line which passes through the point. So they gave a point and it's parallel to the line. So I've already told you that when you are solving an equation of a line and a point is given and gradient is given, you know the formula to use. So if you use this formula, so using this formula, y minus y1 equals to m, that is, gradient is the m now, equals to m, open bracket, x minus x1. So this is the formula you are using. If you use this formula to solve this question, you will get your answer. A point is given, a line is given, but take note now, this line that is given is parallel to another line. It is that line that is parallel to that the question says we should find the equation. So find the equation of a straight line which passes through this point. So that straight line you want to find the equation passes through this point, but the line is a parallel line to this. You understand what we are saying? It's a parallel line to this. So how do we get the equation? So this is the formula we are going to use. Because we have a point, we are going to have a gradient. So what did we say about the gradient of parallel line? The next thing you need to do is make y the subject of this formula. So make y the subject make y the subject. So make y the subject of the equation. So by the time you make y the subject of the equation, you are going to end up in the general form of equation, which is 2x. So we are making y the subject, so y will be equals to, so y is going to be equal to, so plus 2x will become minus on the other side, minus 2x is crossing over, it will become minus 2x, then plus 6 is already plus here, which is plus 6. So that is it. That is it. Then if you recall our last class, I told you that when you make y the subject of the equation of a line, when y is the subject of the equation of a line, all you need to do is to pick the coefficient of x. Now say therefore the coefficient of x, so therefore now, so therefore the, okay, so therefore m, which is the gradient now, m will be equals to minus 2. M is going to be equals to minus 2. So that is the most important thing we need. The coefficient of s is the gradient. So gradient is equals to minus 2. And the y-intercept is going to be plus 6. But we don't need y-intercept here. We only need gradient to get the equation of the line they asked us to find. So now that we know that the gradient is minus 2, and what is the condition? We say parallel lines have equal gradients. So if parallel lines have equal gradient, so therefore now the gradient is equal to minus 2. Okay, let me put this statement is supposed to come under this one. So take note of that. So this statement is supposed to come under here. So parallel lines have equal gradients. So that's one condition we said the other time. So if parallel lines have equal gradient, so the gradient of this line is minus 2. So therefore, the gradient of the line we want to calculate is going to be minus 2. We're not going to change anything about the gradient. So now that we have this, just go to your equation now and solve for your equation. So all you just need to do now is just put a statement, the equation of the line is, so let's solve the equation of the line here now, which is y minus, so y1, you go to the point, so y1 is the second coordinate here, which is minus 3. So y minus, you open your bracket because of minus 3, equals to m, we have calculated m as minus 2, so you have your minus 2, open bracket, then x minus, so x1 is the first coordinate, which is 2. X minus 2, that is all. You solve and represent it in the general form of equation. So let's just put it in the general form, and that is all for this question. So we have y minus times minus is going to give us plus 3, then equals to, you open the brackets here, you have your minus 2x, the minus 2 times minus 2, when you open this bracket, it's going to give us plus 4. Then if I take collection of like terms, when 3 move over, I'm going to have y is equals to minus 2x, then plus 4 minus 3, and that is going to be equal to y is equals to minus 2x plus 1. So that is the answer to this question. So you can see the only difference between these two questions is the y-intercept. That is the only difference. You can see that the y-intercept for the one they asked us to find, the y-intercept is plus 6, while the parallel line that we just solved now, the y-intercept is plus 1. So if I put my answer in this form, putting the x first, I'm going to have, let me put the x first according to the way the question put the equation. I'm going to have 2x plus y, 2x plus y equals to 1. So that is it. So that is the answer to this second question. And if you want to test this question to see if your answer is correct. All you just need to do is, this is the point, 2 and minus 3. Let me go to this place. Let me remove this. Okay. So the first point, let's locate it. It said 2 and minus 3. So when x is 2, y is minus 3. So let me move the graph up. When x is 2, y is minus 3. So this is the point. Let's put the name and the value so that you can see it. So that is the point. Then there's a line. Let's impute the line. The line is 2x plus y equals to 6. So that is the line that is giving 2x plus y equals to 6. You can see the line over there. So this is the line. So there's a line that passes through this point, and they say this line is parallel to this line. So this is the line we just calculated, and I told you the line that was given, the y-intercept is 6. You can see it down here. You can see it when we made y the subject. You can see that the y-intercept is 6. Then the gradient is minus 2. Then the new line we just calculated, now this is the new line we just calculated. It has the same gradient, but the y-intercept is going to be 1. So if I impute this line, now you see that this line is going to pass through that point we just put, that is this point 2 comma minus 3 is going to pass through there, and the y-intercept is going to be plus 1. So that's how you know if your calculation is correct. So the answer we just got is 2x plus y equals to 1. Let's put it there. So we say 2x plus y equals to 1. You can see that it's very correct and perfect. See, as I type it, you can see the line passes through this point and it's parallel to this point, and it passes through plus 1 in the y-axis. So these are proof to know that you are correct. That is why I say you can use graph to solve the question, but in this topic we don't need graph. They want you to solve it using your formulas that are given. So before we go, let's still do one more on perpendicular line, similar to this, but just the condition that is different. So for perpendicular line, let's see the example here. Okay, for perpendicular line, and pick this from JAM question, and it's also similar to the first one. The only difference is this is perpendicular. So say find the equation of a straight line which passes through the point. So it passes through minus 2, 3, and it's perpendicular to this line. So all they want us to do here is, we are still using the same equation. So let me make y the subject here. So you already understand what we are doing. Let me not waste time writing statement again. So if I make y the subject here, I'm going to have 3y is equals to plus 4s and minus 5. We'll come to the other side of the equation. This is going to be minus 4x, then plus 5. You know what happened? Plus 4 will become minus when it crosses over this into the next side. The minus 5 will become plus when it crosses over. So that's how I got this. Then the next thing is to divide each term. I'm going to divide each term by 3. So 3 divided by 3 here is going to give me y. So y is going to be equals to minus 4 divided by 3x, then plus 5 divided by 3. So this is the equation of the line. So this is the equation. So this is the gradient intercept form of this line that is given. So we need a line that is perpendicular to this line and it passes through this point. That's what the question is talking about. So a line that is perpendicular to this line, what will the gradient be like? So remember condition for perpendicular line. You say perpendicular line, that is for perpendicular now. For perpendicular lines, what we said in the other time was, we said M1 M2. When you multiply both gradient is going to give us minus 1. So this was the condition we proved for perpendicular line in our last class. So take note of that. So this is the condition. So if this is the condition of perpendicular line, so let's see now the first line. Let's take M1 as the line they want us to find now. Find the equation of a straight line which passes through this. So let's take M1 as the line we need. So M2 is this gradient. So let's do it now. So if M2 is equals to minus 4 over 3. See, then therefore M1, which is the one we are going to use. So M1 means divide both sides by M2, which is minus 1 divided by M2. So M1 is now going to be equals to, when you divide both sides by M2, you are going to have minus 1 over M2. So this is what we are going to have. And when you move further, you are going to have minus 1 divided by, we put our division symbol. So minus 1 divided by minus 4 over 3. Yeah. Then when you remove this symbol, of when you remove division, plus 3 will come up, minus 4 will come down. So we are going to have M1 will now be equals to 3 over 4. No, let me just put it down, which is minus 1 times 3 divided by minus 4. So this is what we are going to get. This is what we are going to get. Yeah, so now when you cancel minus 1 divided by minus 4, minus divided by minus is plus. So your answer is now going to be 1 times 3, which is 3. So M1 will now be equals to 3 divided by 4. So that is the gradient of M1. So this gradient now we are now going to use it to solve the equation of that other line that they asked us to find. So what are we going to do here? Let me solve it here. The next thing is use our equation y minus y1. So y1 is 3, which is 3 equals to, gradient has been found, which is 3 over 4. Then open your bracket, 3 over 4, which is the gradient m bracket x minus x1, which is minus 2. So you also put it in bracket minus 2. So that is it. The next thing is for us to open our bracket and we end the solution. So y minus 3 is going to be equals to 3 over 4. Then open your bracket. Then when you open the bracket, minus times minus is going to give us x plus 2. So that is that. Then we now have y. Okay, before we do this, let's multiply. Since this denominator is 4, let's multiply each term by 4. When you multiply each term by 4, so that the equation will be easy for us. Let's clear off this fraction. So we are going to have 4y. 4 times y is 4y. Then 4 times minus 3 is going to give us minus 12, equals to 4 times 3 is 12. 12 divided by 4 is going to give us 3. Then you open your bracket, x plus 2. So that is that. Then let's put the equation in this form. Let's just leave it in this form. But before we do that, let's open this bracket. We're going to have 4y minus 12 equals to 3x. When you open the bracket, 3 times x is 3x. 3 times 2 is going to give us plus 6. Then the next thing is, since I want my answer to be in this form, I'll bring 3x to the other side of the equation. I'm going to have minus 3x, then plus 4y, minus 3x plus 4y equal to Then I'll take minus 12 to the other side. It will become plus. To come and meet 6 here, which is 6 plus 12. 6 plus 12. Then finally, to leave it in final form, we have minus 3x plus 4y equals to 6 plus 4, which is 18. So this is our answer for the second question. So the equation of this line that passes through this point is this. So the line that is perpendicular to this line that passes through this point is this equation. So let's also demonstrate it here before we go for today. So if I remove the previous one I did here. Okay, so let me put this point in the right place. So the point that is given is minus 2 for x, 3 for y. So if I move my point, when x is minus 2, y is 3. So this is the point. Then we have an equation. Let's put down the equation. So 4x plus 3y minus 5 equals to 0. So this is the equation that was given, which is 4x plus 3y, 4x plus 3y minus 5 equals to 0. So you can see we have already plotted the graph now. So this is the line, this is the equation. 4x plus 3y minus 5 equals to 0. So what the question is talking about is there's a line that passes through this A and is perpendicular to this line, and that is what I just calculated. So I calculated it as this now. So let me type this now. So I type this in my GeoGebra software now. The line I'm supposed to get will pass through that point and it's supposed to be 90 degrees to that line. If it give us that, then we know that we are in order and we are okay. So let's see and check. So if I type the equation, I got minus 3x plus 4y. Let me check again. Minus 3x plus 4y equals to 18. 3x plus 4y equals to 18. You can see, perfect. See it. So this answer we got, you can see that the line that I just typed now, it passes through this line and is perpendicular to this line. If you check the angle, we say perpendicular is 90 degrees. So angle between this line and this line, you can see it is 90 degrees. So that means our solution is correct. See, 90 degrees. So that is all I have for you today. I hope you enjoyed this video, you enjoyed this class. So this is how to solve question on parallel lines and perpendicular lines and intersection of two lines. So go through the video again. The class is not a difficult one, it's a very simple one. Just follow my previous classes, follow the videos of the previous class. You see how I derive all the equations I used today, and you can practice these few questions as assignment questions. You can see the first one, they gave you the equation, the line, and they gave you a point to find the equation of the line that is parallel to this point and it passes through this point. You can also use your graph sheet to practice it. It's a good way to learn. When you are practicing, practice with every device you have. You can see what I did in checking my answers with graph. You can do it while practicing. When you are used to it in exam condition, you see that you will be very smart in answering your exam questions. You will be sure of your answers. You will not doubt your answers. So we see number 2 is similar to number 1. They are the same parallel lines. Number 3 is perpendicular line. Then number 4 is just a little bit tricky, but it's not a tricky one because we have done distance. We say we should find the distance between the point. So we have also done distance between 2 points. You can do this. So they gave you a point and they say find the distance between this point and a point again and the point common to the line. So you see we have 2 lines. So this is intersection lines now. See, and the point common to the lines, this and this. So if you solve these 2 lines simultaneously, where they meet each other, you'll get the 2 answers, x and y, and that is the point where they meet. And from that point where they meet, take a line to this cube, that will be the distance. So all they wanted to do is find the point of intersection of these 2 lines. As you get the point of intersection, then use it to calculate the distance between 2 points, which is this point and that point. So that is all for the practice question. So take care and have a nice day. Bye.